close your eyes for a moment and take a deep breath. Imagine yourself floating gently in space, enveloped by the velvety darkness of the cosmos, where billions of stars twinkle like distant candles in the vastness of the universe. Tonight, we will embark together on a contemplative journey through time and space, discovering fascinating secrets about how we measure the most extraordinary distances the human mind has ever conceived. Have you ever stopped to think that when we look at the stars, we're not just observing distant points of light, but veritable time machines? Each beam of light that reaches your eyes carries with it a journey story that may have begun long before you were born. And to comprehend these unimaginable distances, astronomers created a poetic and profound unit of measurement: the light year. Here's something curious that might surprise you as you settle into your pillows. A light year doesn't measure time, as the name might suggest. In fact, it measures distance. It's the distance light travels in an entire year, journeying through the vacuum of space at a speed that defies our everyday understanding. Light travels at an incredible 299,792 kilometers per second. It's so fast that if you could travel at that speed, you would circle the Earth 7.5 times in just 1 second. Just a blink of an eye. Now, let that extraordinary speed work for an entire year. Second after second, minute after minute, day after day. When we add up that entire journey, we arrive at a distance of 9.46 trillion kilometers. This number is so large that we can barely visualize it. That is the measure of a single light year, and it is with this cosmic ruler that we map the universe around us. The closest star system to us, called Alpha Centauri, is 37 light years from Earth. Think about that for a moment. The light you would see from those stars today, if you could observe them in the night sky, is not the light being emitted right now, at this very moment. It is light that began its journey in 2021. While you were living your life a few years ago, those photons were already on their way, traversing the icy void of space to finally reach your eyes here, in 2025. And this perspective leads us to an even deeper and more poetic reflection. If, for some impossible reason, our planet Earth were to disappear this instant, a hypothetical civilization living 10 light years away would only discover this tragedy in 2035. For an entire decade, they would continue to see our small, pale blue dot shining peacefully in the sky, completely oblivious to the fact that it no longer exists. The universe, you see, operates in a kind of cosmic lag, where present and past intertwine in ways that defy our intuition. Everything we see in the universe is, in essence, the past. There is no universal now when we look at the cosmos. Some galaxies that we can observe are millions of light years away, which means that the light we receive from them today came out when dinosaurs still roamed the Earth. When you look at these galaxies through a telescope, you are literally looking at a world that existed in a geologically earlier era than our own. Consider the Andromeda Galaxy, our nearest cosmic neighbor. It lies, 5 million light years away. The light we see from it today, shining softly in the autumn night sky, began its journey before modern humans even existed on Earth. When that light left Andromeda, our most distant ancestors were still primitive creatures learning to use stone tools. And now, all this time later, that light finally reaches us, carrying a silent message from an almost incomprehensible past. Our own galaxy, the Milky Way, That milky band that stretches across the sky on dark, clear nights is about 100,000 light-years in diameter. If light could travel from one side of this immense spiral of stars to the other, it would take 100,000 years to complete the journey. Think about that as you breathe slowly and feel your body relax. The light that travels through our galaxy began its journey when humanity was still emerging as a species, long before the pyramids, before writing, before any civilization we know of. And if you think 100,000 years is a long time, prepare yourself for something even more dizzying. The most distant galaxies that astronomers have managed to observe are more than 13 billion light-years away. When we look at these primordial galaxies, we are literally observing the newborn universe, right after the Big Bang. We are seeing light that has traveled through almost the entire history of the cosmos to finally reach our telescopes. It's a window into the infancy of the universe itself. When scientists talk about billions of light-years, they're not just describing unimaginable distances. They're talking about time, about history, about the very birth of reality as we know it. There's something called cosmic microwave background radiation, a kind of luminous echo of the Big Bang, which is approximately 46 billion light-years away on the surface of the observable universe. It's the farthest we can see, the ultimate frontier of all that can be known. Now, bring your mind back to something a little closer to home, something that might help us understand these distances in a more tangible way. Even with the most advanced space technology humanity has ever developed, it would take us tens of thousands of years to reach just the nearest star. If we could build a rocket capable of traveling at 10% of the speed of light, something far beyond our current capabilities, it would still take us 44 years just to reach Alpha Centauri. A lifetime of travel to reach our nearest stellar neighbor. The exoplanets detected by the Kepler Space Telescope, these distant worlds orbiting other stars, are tens or even hundreds of light-years away. When astronomers observe them, they are seeing these planets as they were in the 19th century. While these distant worlds swirled in their orbits, here on Earth, the Victorian era flourished. The Industrial Revolution transformed societies, and no one even imagined that one day we could detect planets around other stars. When you look at the night sky on a clear night, far from the city lights, each star you see has a different age in terms of the light that reaches your eyes. Some are only 4 light-years away, showing us what they looked like a few years ago. Others are thousands of light-years away, revealing a past that goes back to eras we can barely conceive. The night sky is, truly, a living museum of time, and here's a comforting thought as you drift off to sleep. If the sun were to disappear right now, you wouldn't know immediately. You would continue to see its light for 8 minutes and 20 seconds before realizing the tragedy. This distance between the Earth and the Sun is measured in light minutes, and it reminds us that even the star that gives us life operates within this cosmic lag. Everything we see of the Sun happened more than 8 minutes ago. We perpetually live in the solar past. The center of our own galaxy, where a supermassive black hole resides, is 26,000 light-years away. When we observe the core of the Milky Way, we see what it was like when humans still lived as hunter-gatherers, painting animals on cave walls and beginning to domesticate plants and animals. The entire history of human civilization happened in the time it took for that light to travel to us. And there is a fascinating and slightly melancholic possibility that should accompany you into your dreams. A galaxy that we observe 500 million light-years away may no longer exist. It may have collided with another galaxy, its stars scattered, its planets destroyed. But its light is still traveling to us, crossing the void, carrying the image of a place that is no more. It's like receiving a letter from someone who has already passed away, written long ago. When we say that something is so many light years away, we are doing much more than simply measuring the space between 2 points. We are merging distance and past into a single, elegant unit of measurement. We are acknowledging that, in the cosmos, the where and the when are inseparable. Every point of light in the sky is simultaneously a place and a time, a location and a memory. As you lie in your bed, under the same sky that our ancestors contemplated millions of years ago, remember that you are connected to this entire vast universe by these invisible threads of light. Each photon that touches your eyes has traveled distances that defy imagination, carrying stories of places and times that we may never be able to visit, but that we can know through this extraordinary window that is starlight. Now, let me guide you deeper into this journey, exploring what it truly means to travel across these cosmic distances. Because it's one thing to contemplate the poetic beauty of a light year, but quite another to comprehend the absolute, almost impossible scale of that measurement when confronted with our human capabilities. Traveling a single light year would require such an absurd amount of energy, so far beyond any technology we currently possess, that we can't even achieve 1% of it. Our most advanced spacecraft are like ants trying to cross a continent when compared to the vastness of a light year. To put this into even more humble perspective, imagine our sun, that majestic star that governs our solar system. If the sun could somehow travel at the speed of an ordinary car on the highway, it would take 200 million years to travel just 1 light year. 200 million years. Longer than the dinosaurs reigned on Earth. Even our fastest probes, like the impressive Parker Solar Probe that currently holds the speed record for man-made objects, would take more than 6,500 years to traverse a single light year. That's longer than the entire history of human civilization as written. You could start the journey around the time the first cities were being built in Mesopotamia, and you still wouldn't have reached your destination today. This immensity has a curious and almost hypnotic effect when we observe the sky. The light year is so incredibly large that even the nearest stars appear completely motionless when we observe them. They do not move perceptibly across the night sky. Only after decades of careful observations, comparing old photographs with new ones, are astronomers able to detect the subtle movement of these stars through space. To our eyes, and even to our instruments over a human lifetime, they appear fixed like eternal diamonds on black velvet. The nearest star to us, called Proxima Centauri, lies 24 light-years away. And that, believe it or not, is already considered our immediate neighbor in the universe's standard. It's as if we lived on an isolated farm, and our nearest neighbor was on the other side of the horizon, in a place that would take us more than 6 millennia to reach with our fastest vehicles. Our entire galaxy, the Milky Way with its billions of stars swirling in a cosmic dance, is about 100,000 light-years in diameter. And here's something that might surprise you as you sink deeper into your pillows. That's only an average-sized galaxy. We are neither particularly large nor small in the grand scheme of things. There are entire dwarf galaxies that could fit within a single radius of just 10 light-years around the Sun. Complete island universes, with millions of stars, occupying a space we consider minuscule on a cosmic scale. To further understand this dizzying scale, consider that 1 light year is equivalent to 63,241 astronomical units. An astronomical unit is the distance between the Earth and the Sun, approximately 150 million kilometers. And yet, we need more than 63,000 of these distances to form a single light year. Our entire solar system, with all its planets, moons, asteroids, and comets, is absolutely minuscule when measured on this scale. It's like comparing a grain of sand to an entire beach. The sunlight that warmed your skin today took 8 minutes to reach you, but that same light needs approximately a year to reach the Oort cloud. That distant and icy region on the fringes of our solar system where billions of comets sleep in slow orbits. Even within our own cosmic neighborhood, the distances are so vast that light, with all its unimaginable speed, needs a whole year to reach the far reaches of our home. And now, allow yourself to contemplate something truly fascinating as your eyelids begin to droop. When we look at a star 50 light years away, we are seeing the Earth of the 1970s reflected in cosmic time. If there are planets around that star, and if there are observers on those planets with powerful telescopes looking back, they would be seeing our Earth as it was half a century ago. They would see the era of early computers, the Cold War, the social movements that transformed the world. All of this would be the present for them. Now, imagine civilizations living 500 light years away. If they pointed their telescopes at our small blue Earth right now, what would they see? They would be observing the Renaissance era. They would see an Earth where Leonardo da Vinci was still painting, where great voyages of discovery were redrawing maps, where modern science was just beginning to emerge. For them, Shakespeare hadn't yet written his plays, Newton hadn't yet discovered gravity, and the Industrial Revolution was a distant and unimaginable future. When we gaze at the Andromeda Galaxy, that magnificent spiral of stars visible to the naked eye on dark nights, we are seeing it as it was 2.5 million years ago. At that time, long before modern humans existed, our most primitive ancestors were still learning to use stone tools in Africa. The human species as we know it today did not yet exist. And yet, the light that left Andromeda in that distant time is reaching our eyes now, bringing news of a forgotten era. Astronomers chose to use light years to measure cosmic distances for a very practical reason. Numbers in kilometers would simply be impractical. Imagine trying to say that Andromeda is 23 quintillion and 600 quadrillion kilometers away. The number is so absurd that it loses all meaning. But saying 2.5 million light years, that our minds can, at least, begin to process. If we shrunk the sun to the size of a basketball, just to try and visualize these proportions, a light year would be equivalent to more than 50 complete trips around the Earth. Even reducing the sun to something you can hold in your hands, the scale of a light year remains absurdly gigantic. The map of the universe that we can see through our telescopes is not a snapshot of the cosmic present. It is, in fact, a complete historical archive, a record frozen in time of billions of years of cosmic history, all happening simultaneously before our eyes. When you look at the night sky, you are literally looking through time. The farther your gaze reaches, the older the universe you see. It is a natural time machine, built by the very physics of the cosmos. The James Webb Space Telescope, this marvel of human engineering floating in space, observes galaxies that are more than 13 billion light-years away. It is seeing light that left when the universe was only a few 100 million years old. It's like looking at a baby photo album of the cosmos itself, seeing the first stars and galaxies forming in the primordial darkness. The oldest light we've ever been able to detect traveled for 8 billion years before reaching our instruments. That's essentially the age of the universe. But here's something that might seem paradoxical as you drift off to sleep. Although the universe is 8 billion years old, it measures about 92 billion light-years wide today. How is that possible? Because space itself is expanding. Galaxies aren't just moving away from each other through space. The very fabric of space is stretching, expanding, growing like a mass of bread rising in an oven. The concept of a light year, when you really think about it, is an elegant fusion of three of the most colossal ideas the human mind has ever conceived: time, distance, and the speed of light, all intertwined in a single unit of measurement. It's a way of capturing the fact that, in the universe, these three things are inseparable. You can't talk about distance without talking about time. You can't talk about observation without talking about the past. And here is the final reflection from this part of our journey. Something to take with you into your dreams. Every light year we travel away from Earth, whether with our imagination or our telescopes, is like traveling back in time in the very history of the cosmos. We are not just exploring space when we look at the stars. We are exploring time. We are cosmic archaeologists, excavating layers of ancient light, discovering secrets of eras that existed long before any human being first breathed. Take another deep breath. Feel your body sink into the mattress, each muscle relaxing as we continue our contemplative journey through the wonders of the cosmos. Let's revisit some of these extraordinary concepts from different angles, allowing them to settle gently in your mind like snowflakes falling on a quiet winter night. Perhaps it's worth repeating, because it's so counterintuitive. A light year doesn't measure time, despite the name confusing so many people. It's one of the most beautiful ironies of astronomy. We use the word year to describe something that is fundamentally about distance. But this confusion is understandable, because the concept itself unites these two dimensions so intimately that they become almost indistinguishable. Think again about that sunlight. It takes 8 minutes and 20 seconds to travel from the sun's surface to reach Earth. During that time, it traverses the icy vacuum of interplanetary space, passing through the orbit of Mercury, then Venus, until finally bathing our world in warmth and light. And here's that reflection that always brings a strange feeling of vulnerability. If the sun disappeared right now, at this very instant, you wouldn't know. You would continue seeing its light, feeling its heat reflected by the atmosphere, living your life normally for 8 whole minutes before realizing the catastrophe. This distance between us and our parent star is measured in light minutes, and it reminds us of the fragility of our existence and the delicate fabric of space-time. The closest star to us after the Sun remains Proxima Centauri, that distant neighbor 24 light-years away. And here's a different way to think about it as you prepare for bed. The light you would see from that star today, if you had a telescope pointed at it, actually came from there when you were 4 years younger. Think about where you were 4 years ago. What were you doing? Who were you? The light that's reaching us now from Proxima Centauri carries a photograph of that moment, frozen in space as it traveled to here. even if we built the fastest spaceship imaginable with our current technology, it would still take us tens of thousands of years to reach that neighboring star. Entire generations would be born and die during the journey. Entire civilizations could arise and fall to Earth before the ship reached its destination. The vastness of space is so absolute that even our nearest neighbor remains effectively unreachable for us, at least for now. Our galaxy, this vast swirl of stars, is about 105,000 light-years in diameter. That represents the distance that light, traveling at the maximum possible speed in the universe, would take to cross from one side to the other. 105,000 years of uninterrupted travel at the fastest speed that exists. It's almost impossible for our minds to truly grasp that scale. It's like trying to imagine a number with so many zeros that it loses all practical meaning. When we see objects millions of light years away, we are literally looking at prehistoric cosmic times. A galaxy observed 30 million light years away is being seen exactly as it was 30 million years ago. At that time, on Earth, the first primates were beginning to evolve. Primitive mammals roamed forests that no longer exist. Continents were in different positions. The world was almost unrecognizable compared to what we know today. And yet, the light from that distant galaxy, which departed at that unimaginable time, is only now reaching our telescopes. Andromeda, our majestic galactic neighbor, is too 5 million light-years away. What we see when we look at it is a reflection of what it was like even before humans existed, before any member of our species walked the Earth. The light we see from Andromeda today carries the image of a galaxy that existed in an era when our planet was inhabited only by creatures who would never know our names, never build cities, never look at the sky and wonder about their place in the cosmos. The starlight we see in the night sky is always, without exception, a journey into the past. There is no way to see the cosmic present. The fundamental physics of the universe guarantees that we are eternally looking back in time whenever we look up. And the more distant the object, the older the moment we are observing. It is an immutable law of the cosmos. Distance and time are two sides of the same coin. Some of the objects we observe are so incredibly far away that their light left when Earth was still covered by primitive oceans, when life on our planet consisted only of simple molecules floating in warm, shallow seas, when the first oxygen atom had not yet been released by a cyanobacterium. These photons traveled through all that time, witnessing the evolution of our planet from a barren world to a vibrant garden of life, until finally being captured by a telescope built by creatures that evolved from those primitive oceans. The James Webb Space Telescope is revealing galaxies that are 13 billion light-years away. Let that number settle gently in your mind as your eyelids grow heavier. 13 billion years. That means we are observing the universe when it was less than 5% of its current age. We are seeing the cosmos in its infancy, just after the first stars lit up in the primordial darkness. It's like finding photographs of when you were only a few weeks old, but on a scale that spans all of existence. The farther we can look with our increasingly powerful telescopes, the more we see the universe in its delicate infancy, almost immediately after the Big Bang. We are literally observing the birth of reality itself. The first lights that ignited in the infinite darkness. The first structures forming. The seeds of galaxies that would one day give rise to stars, planets, and eventually observers like us capable of looking back and contemplating our own origin. Distances measured in light years are so incomprehensibly vast that we cannot relate them to anything in our everyday experience. There is no analogy that truly works. They are purely cosmic, existing on a scale that is fundamentally alien to human experience. We can pronounce the numbers, we can do the calculations, but truly comprehending these distances, that is beyond our minds evolved to navigate African savannas and recognize faces. If we were able to build a spaceship capable of traveling at 1% of the speed of light, something that would be an extraordinary technological achievement, it would still take us 100 years to travel just a single light year. An entire century of travel to cross 1 unit of cosmic distance. And remember, the nearest stars are several light years away. The Milky Way is over 100,000 light years wide, and there are billions of galaxies beyond our own. Voyager 1, that small ambassador of humanity now sailing in interstellar space, is the fastest traveling and farthest traveling man-made object. It is leaving our solar system, carrying a golden record with sounds and images of Earth, a message in a bottle launched into the cosmic ocean. But even traveling at the impressive speed it has achieved, Voyager 1 would take more than 17,000 years to travel a single light year. 17 millennia, longer than the entire history of human civilization. And it has been traveling for decades and has barely left our cosmic backyard. The concept of a light year is not merely convenient. It is absolutely essential to our understanding of the universe. Space is so vastly, incomprehensibly large that even astronomical numbers measured in kilometers or miles seem small and inadequate without this special unit. It's like trying to measure the distance between continents in millimeters. Technically possible, but completely impractical and devoid of intuitive meaning. Every time we pronounce light year, we are acknowledging a fundamental truth about the cosmos, that it is larger than we can comprehend, older than we can imagine, and more mysterious than we will ever be able to fully unravel. And yet, here we are, tiny creatures on a small rocky planet, capable of measuring these distances, understanding these concepts, gazing into infinity, and trying to give it a name. Close your eyes again. Let your breath deepen, slow and rhythmic, as we delve even deeper into the mysteries of light traversing the cosmos. Let's explore not only the distances, but what they mean for our understanding of reality, of time, and of our place in this infinite universe. If you could, by some miracle of physics, travel at the speed of light, it would take you only 8 minutes and 20 seconds to reach the sun. 8 minutes. Less time than it takes you to have a leisurely breakfast. And yet, that's an absolutely ridiculous fraction when compared to the total size of the universe. It's like comparing a step to a walk around the planet. The sun, which seems so distant and unattainable to us, is practically next to us when we think in cosmic terms. To reach Proxima Centauri, our nearest stellar neighbor, it would take you 4 years and 3 months, even traveling at the fastest speed in the cosmos. 4 years of uninterrupted travel at the maximum speed physics allows. Think about it. You would start the journey today and only arrive at the end of 2029. Your entire life would change in that time. People would be born, grow up, the world would transform, and you would still be traveling through the void between the stars. The amount of energy required for a journey of 1 light year is so absurd that we can hardly express it. It would be equivalent to all the power plants on Earth operating continuously for millions of years. All the energy that humanity consumes, all the electricity it generates, all the power we have managed to harness since the beginning of the Industrial Revolution, multiplied by millions. And that would only be enough to traverse a single unit of cosmic distance. Every light year we travel mentally, every time we let our imagination wander among the stars, is fundamentally a journey into the past. Because we are always seeing light that departed years, decades, centuries, or millennia ago. The cosmic present is invisible to us. We live perpetually surrounded by luminous ghosts of the past, images of stars and galaxies as they were, not as they are. That star you see shining in the night sky, it may already be dead. It may have exploded in a supernova decades ago, scattering its atoms across space, seeding clouds of gas with the elements that will one day form new planets, perhaps even new life. But its light continues to travel, traversing tens or hundreds of light years before finally reaching your eyes. You are seeing a stellar ghost, the luminous memory of something that may no longer exist. And here's something that should bring comfort as you sink deeper into sleep. Our brains weren't built to imagine light years. We weren't designed by evolution to comprehend those scales. Our ancestors needed to understand hunting distances, walking distances, the reach of a spear. Our spatial intuition works well up to a few kilometers, maybe even hundreds. But trillions of kilometers. That's completely beyond what our neurology can intuitively process. That's why those distances seem so impossible to grasp. It's not your fault. It's simply that we're trying to use mental tools that are inadequate for the task. The Andromeda Galaxy rests serenely in the autumn sky. 5 million light years away. When you look at it, you are seeing the galaxy exactly as it was when the first members of the Homo genus walked the African savannas. Before any words were spoken, before any complex tools were created, before any cave paintings, the light you see departed in an era where humanity was merely a distant promise, an evolutionary possibility yet to be realized. A spacecraft traveling at the fastest speed ever achieved by humanity would take 45 million years to travel a single light year. 45 million years. When that journey began, primates would only be beginning to evolve. When it ended, who knows what creatures would dominate the earth? What civilizations would have risen and fallen? What oceans would have dried up? What mountains would have been eroded by wind and rain? A light year contains approximately 46 trillion kilometers. It's a distance so incomprehensibly vast that entire planets like Earth could fit within it billions of times over. You could line up Earths one after the other and still not fill a significant fraction of a light year. It's like trying to fill an ocean with dewdrops. If you were to take a hypothetical journey of 100 light years across the galaxy, you would traverse regions with such dramatically different stellar densities that the night sky itself would change completely during the journey. In some areas, you would navigate through dense clusters where thousands of stars compete for space, illuminating the sky in a perpetual glow. In others, you would find vast voids where darkness reigns almost absolute, with only distant points of light piercing the infinite blackness. To understand the scale, imagine that our entire galaxy, with its 100,000 light years in diameter and billions of stars, were shrunk to fit on a dining table. At this reduced scale, a single light year would be approximately the size of a grain of sand. A tiny grain, almost invisible. And yet, in reality, this grain contains trillions of kilometers of empty space. Massive stars, those giant blue stars that burn with fierce intensity, illuminate the space around them for hundreds of light years. They create veritable bubbles of light within the total darkness of interstellar space. These stars are so luminous that if you were 100 light years away, you could still see them shining brightly in the sky. They are cosmic beacons, announcing their presence across distances that would make planets and even entire solar systems seem insignificant. Supermassive black holes, those gravitational monsters that slumber at the center of galaxies, distort light for light years around them. They bend the very fabric of space-time with their overwhelming gravity, creating gravitational lenses that cause the light from distant stars to bend and dance. It's as if these objects have invisible hands that manipulate the reality around them, shaping not only space but the very flow of time. Fragments of ancient galaxies, debris from cosmic collisions that occurred billions of years ago, are still traveling through intergalactic space, traversing light years with infinite patience. They are like fossilized messages from the distant past, carrying in their chemical composition the history of cataclysmic events that shaped the universe. Each atom in one of these fragments has a story to tell, if only we could learn the language. Some star clusters contain thousands of stars separated from each other by only a few light years. They are true cosmic condominiums, stellar neighborhoods where stars are born together from the same cloud of gas and remain gravitationally bound for millions or billions of years. If you could visit a planet orbiting a star in one of these clusters, the night sky would be spectacular, filled with bright stars so close together that there would be no true darkness, only a perpetual twilight illuminated by hundreds of distant suns. But space also has its deserts. The empty regions of the cosmos, those vast voids between clusters of galaxies, have areas where, for hundreds or even thousands of light years, there isn't a single star, only absolute darkness, occasionally interrupted by a solitary hydrogen atom floating in the void. If you were in these regions, you would look in every direction and see only black, with distant galaxies appearing as pale, unreal smudges at the edges of your vision. When a massive star reaches the end of its life and explodes in a supernova, its light can travel for 1,000 light years or more, illuminating dust and gases along the way. The explosion is so bright that, for a few weeks, a single dying star can shine more intensely than billions of normal stars combined. The light from this explosion travels through space, energizing clouds of gas, causing them to glow with vibrant colors that persist for millennia. It is the stellar swan song, a final declaration of existence that echoes across unimaginable distances. Here's a dizzying thought to accompany you to sleep. If we could travel 1 light year per second, something that would be faster than light itself, it would still take us 30 years to cross the entire Milky Way. 30 years traveling faster than physics allows, just to go from one side to the other of a single galaxy. And there are billions of galaxies in the observable universe. The light that leaves Earth today, carrying images of our cities, our satellites, all the radio and television waves we transmit into space, will only reach the Andromeda Galaxy in 2.5 million years. By then, if humanity still exists, it will be such a transformed species that we would hardly recognize ourselves. Or perhaps we will no longer exist at all, having become extinct or evolved into something so different that we would be unrecognizable. And yet, our light will continue traveling. A message in a bottle launched into the cosmic ocean. perhaps to be found by someone, perhaps to wander eternally. And to complete this circle of observation through time, consider this while closing your eyes. Some planets orbiting stars hundreds of light years away may be observing us right now. If there are alien astronomers with powerful telescopes pointed in our direction, they are not seeing the Earth of today. They see us as we were in the Middle Ages. They see a world of castles and knights, of kingdoms and empires that no longer exist. They know nothing about cars, airplanes, computers, or space travel. To them, we are medieval, stuck in an era that for us is ancient history. And perhaps, on some distant planet, someone is looking at us and wondering if there is life on this small blue dot, without knowing that, yes, we are here, looking back across the centuries of light that separate us. Breathe. Let your body completely surrender to rest as we contemplate together the final wonders of this cosmic journey. We are nearing the end of our exploration, but the revelations that await us are perhaps the most profound of all. If we could build a spacecraft capable of traveling at 1% of the speed of light, something that would be an extraordinary triumph of human engineering, it would still take us 400 years to travel the mere 4 light years to Alpha Centauri. 400 years. Longer than the United States has existed as a nation. Longer than the entire scientific revolution. Countless generations would be born and die during that journey, and we would still only be visiting our nearest stellar neighbor. Light, at its dizzying speed, can circle the Earth 7 times in a single second. 7 circumnavigations in less time than it takes to blink. And yet, that same light, so incredibly fast, would need 100,000 years to cross our galaxy from one side to the other. What seems instantly fast on our human scale becomes almost painfully slow when confronted with the true distances of the cosmos. A light year measures exactly 9,460,730,472,580 kilometers. Try to visualize that number. Try to give it some concrete meaning. It's impossible, isn't it? That number is so incomprehensibly large that it almost makes no sense to the human brain. We can pronounce it, we can write it, but truly comprehend it. That is beyond our cognitive capacity. A beam of light emitted at this very moment will only reach the edge of the observable universe in 13.8 billion years. That's almost the entire age of the universe itself. This photon would begin its journey now, and only reach the confines of the known cosmos when the universe is almost twice its current age. Entire stars will be born, live their full lives, and die during this single journey of light. Distances measured in light years are so enormous that even light, that universal standard of speed, the maximum limit that physics allows, seems slow. When we think on a cosmic scale, even 300,000 kilometers per second seems like a crawl. It's humbling to realize that not even the fastest possible speed is enough to make the universe conveniently navigable. Our sun, that star that seems so fixed in the sky, actually orbits the center of the Milky Way in a majestic journey that lasts 225 million years. A complete cosmic year. During this orbit, the Sun travels trillions and trillions of kilometers, traversing different regions of the galaxy. The last time we were in this position in galactic orbit, dinosaurs had not yet appeared on Earth. And when we complete another revolution, who knows what will have happened to humanity? The Andromeda Galaxy is 5 million light years away, but it's not stationary. It's traveling toward us. In approximately 4 billion years, these two gigantic galaxies will collide in a gravitational embrace that will last millions of years. It won't be a destructive collision, as we imagine, because there's so much empty space between the stars that very few will actually collide. Instead, the two galaxies will dance around each other, eventually merging into a single giant elliptical galaxy. If humanity still exists at that time, it will witness a spectacle in the night sky that defies imagination. If you could observe Earth from a distance of 100 light-years, you would see the planet exactly as it was in 1925. You would see an era of jazz and Art Deco, of early talking films and early radio broadcasts. You would see a world recovering from the First World War and with no idea of the approaching second. All of this would be the present for you, while for us it is history preserved in dusty books. If someone were 10,000 light-years away observing us right now, they would see humans still living in caves. They would see the beginning of agriculture, the first cities emerging in the Fertile Crescent, the first writing systems being invented. They would know nothing about modern civilizations, about technology, about everything we consider essential to human life. To them, we are primitive, barely beginning our journey as a species. A stellar event occurring today in a galaxy 500 million light-years away will only be visible from Earth when new species may have already evolved here. When that light finally arrives, the face of the Earth may be completely transformed. New life forms may dominate the oceans and continents. Humanity may have disappeared long ago, or evolved into something unrecognizable. And that ancient light will finally arrive, carrying news of an event that for us will be incredibly ancient, but which for the light was merely a journey. Some galaxy clusters are separated by billions of light-years. Vastnesses so incomprehensibly large that even using the word large seems inadequate. There is no adjective in human language that truly captures this scale. These are distances that challenge not only our imagination, but our very ability to conceive of distance as a concept. The universe is expanding, and this expansion makes everything even more complex. Many distant objects appear to be even farther away than their light years would indicate, because the very space between us and them is stretching. It's as if we were on an elastic surface being pulled in all directions simultaneously. Galaxies that were a certain distance away when their light left are now much farther away when that light finally reaches us. Some galaxies are moving away from us so rapidly, driven by the accelerating expansion of the universe, that we will never see their light. Even if we traveled at the speed of light for all eternity, we would never reach them. They exist beyond an absolute cosmic horizon, forever separated from us by the fundamental physics of the expanding cosmos. There are parts of the universe that are, by definition, forever inaccessible. Distance in light years can also be used as age. It's a measure that merges space and time into a single elegant unit. When we say something is 1,000 light years away, we are simultaneously saying it's at a certain distance, and that we're seeing it as it was 1,000 years ago. Distance and the past are the same thing in astronomy. There's no separation between where and when. The light emitted by stars that died millions of years ago still travels through the cosmos. They are luminous ghosts in the fabric of space-time, messengers from worlds that no longer exist. These stars exploded, or collapsed into black holes, or simply cooled to darkness. But their light continues its eternal journey, unaware that its source has perished. If you look at the sky tonight, some of the stars you see may already be dead, and you are observing their ghosts. A light year is so immensely large that even an advanced spacecraft capable of traveling at 10% of the speed of light would take 10 years to traverse just one. An entire decade of travel at the fastest speed we can imagine building, just to cross a single unit of cosmic distance. And the nearest stars are several light years away. Our galaxy is 100,000 light years in diameter. The scales accumulate until they become completely abstract. Most of the stars visible to the naked eye in the night sky are less than 1,000 light years away. All those lights you see on a clear night, all those stars that form the constellations that have guided navigators and inspired poets for millennia, are our closest neighbors. They are a tiny drop in a galactic ocean. The vast majority of stars in the Milky Way are far beyond what our eyes can detect, hidden by distance and insufficient light. To truly grasp the scale, consider this. Venus, our neighboring planet, is only 0.06 light years from Earth. This ridiculously small number shows how drastically our measurement standards change as we increase the scale. What seems like an astronomical distance when measured in kilometers becomes almost insignificant when expressed in light years. It's like measuring the distance to your neighbor's house in kilometers, and then trying to use the same unit to describe the distance to another galaxy. The light from the center of the Milky Way takes 26,000 years to reach us. When we observe the beating heart of our own galaxy, we see its deep past. We see what it was like when humans were still learning to domesticate wolves, when the last ice age was beginning to recede, when mammoths still roamed the earth. The core of our own galactic home is, for us, ancient history. The universe is so incomprehensibly large that some regions are separated by distances exceeding 30 billion light years, due to the continuous expansion of space. 30 billion light years. More than twice the age of the universe in distance. How is this possible? Because space itself is expanding, and always has been. Objects that were close together in the young universe are now separated by distances that exceed the age of the universe multiplied by the speed of light. And now, as you are about to drift off to sleep, let me offer a final reflection that captures everything we have explored together. The light year is the ultimate ruler of the cosmos. It doesn't just measure space, though it does so with precision. It doesn't just measure time, though it captures the past in every measurement. It measures history. It measures distance. It measures the very structure of the universe. When we say light year, we are acknowledging that in the cosmos, space and time are inseparable. That distance and history are two sides of the same coin, that looking away is always looking back. The light year reminds us that we are small but not insignificant. It reminds us that the universe is vast beyond comprehension, but not beyond our intellectual reach. We can measure the immeasurable, we can name the unnameable, we can comprehend, at least mathematically, that which we can never experience physically. So sleep now, knowing that you are part of this extraordinary cosmos, that the atoms in your body were forged inside stars that existed billions of years ago and billions of light years away, that the light that touches your skin has traveled through empty space for light minutes, that when you look at the sky, you are looking through time. You are a piece of the universe that has become self-aware, capable of contemplating distances that would make planets seem like grains of sand and eras that would make civilizations seem ephemeral. And in this infinite vastness, here you are, small but unique, temporary but precious, part of the cosmic dance that began 13.8 billion years ago and will continue for countless ages yet to come. Good night. May your dreams take you across light years, exploring distant galaxies and forgotten times, knowing that tomorrow you will wake up here, on this small blue planet, under the same sky that has silently observed all of human history.